Alright, hey everyone, so this is going to be the Hailstone tree function. And so what's going to happen here is like the Hailstone sequence is like if you have a number n, you're going to divide by n, divide by 2 if n is even, and you're going to multiply by 3 and add 1 if n is odd. And the sequence like kind of continues until you hit like n equals 1. And so we're going to write a function called Hailstone tree, and it's going to take in two parameters n and h, and we're going to generate a tree of height h, and it's going to contain Hailstone numbers that reach n. And so what we have here is I'm going to write out the second doc test. So this is Hailstone tree of 8 and 3. So if we notice, we start out at the top, so it's 8. And then, like if you think about like what happens, let's see like what happens with the 10. 10 goes to 5, 5 goes to 16, 16 goes to 8, because like 10 divided by 2 is 5, 5 is odd, 5 times 3 plus 1 is 16, 16 is even, 16 divided by 2 is 8. So like this is a Hailstone sequence terminating at 8. Along with here, we have 6, 64, 32, 16, 8. And so that's another Hailstone sequence of length 3 that will like get to 8. And so the question is, like, how do we even make this tree? Because like it's kind of interesting how we start off at like the last number and then we want to go backwards. So we go like backwards from 8 to 16, to 5, then to 10, which is kind of weird. But let's think about like how we can branch off. So if you think about it, like there are two different ways we can get to like some number, let's say 8. And one, we can have like some number times 3. So x times 3 plus 1 is equal to 8. That's one number that we can come from. And so I don't know if you noticed at all, but if we notice with from 8 to 16, it only has one branch. And so why doesn't it have the x times 3 plus 1 branch? Why isn't there a number that's like where like x times 3 plus 1 is equal to 8? And why don't we have like that number right here? And so that's what we're going to be thinking about right here. And so if we think about it, let's try to find that number that's going to go to 8. Actually, first, let's try to like determine like where 16, 32, 64 comes from. And so since we want to find a number where like x divided by 2 is equal to 8. And also note that like x has to be an integer. And so if we know, like the solution is right here, so like x equals 8 times 2, and that number is going to be 16. And this is valid because 16 is even, so when we consider a Hailstone sequence, if it's even, we divide it by 2. So 16 divided by 2 is going to be 8, which is cool. And so we found one path, which is like if it's a like we multiply it by 2 to get a number that'll like lead to the 8 and things like that. But let's think about like the case in which it's odd again. It's like x times 3 plus 1. And so I'm gonna like make a note right here. 2 times n, that's one way we can go. But what about like x times 3 plus 1 is equal to like some number, let's say n? Well, first of all, let's solve for x. So x is going to be n minus 1 over 3. And so there are some things that we know about this number. First of all, n minus 1 over 3 has to be like divisible by 3. Because if it isn't, then it's going to be like a decimal or like a float. And you know, Hailstone sequences cannot be floats, so that will not be valid. So we have one condition that we want to check. Is n minus 1 divisible by 3? In particular, if n minus 1 mod 3 is equal to 0. So that's one condition that we have to check before we determine, you know, we can go down another path, the odd path. Along with that, we want to check, you know, is this number odd? And so the reasoning behind this is, let's say our number was like 6, and like we were trying to get to maybe the number 17. And we solved this equation, we got that, you know, oh, I think I did the wrong way. Let's say we wanted the number 19. So we solve for x, we get that x is like maybe 6. But the thing about this is that 6 can't actually get to 19. Because the reasoning behind that is, the rule is that if it's even, you have to divide by 2. So if we go to the next term in the Hailstone sequence starting at 6, we have to go to 3 rather than 19 because it's even. And so we need n minus 1 over 3 or x to be odd. And so that's another condition that we have. N minus 1 mod 3, divided by 3, mod 2 is equal to 1. So we're checking if that number is odd. And if that number is odd, well, we're kind of like done there. There's like, yeah, if that number is odd, it's valid. We can have it as part of our Hailstone sequence, like going backwards. So like in the case of like 16, 16 minus 1 mod 3 is like 15 mod 3, which is equal to 0. That's one check. That's pretty nice. And along with that, 16 minus 1 divided by 3, that's going to be 5. And we know that 5 is an odd number. So this all like kind of works out right here. But there is also another situation that I want to consider. And so one thing is that, let's say, let me think of the number. Let's say we're dealing with the number 2. And so what happens here is that, we solve this equation. Oh, maybe the number 4. My bad. I would keep on going the wrong way. Well, let's say n equals 4. And so we solve for x, and we get that n minus 1 is 3. Divided by 3, that's 1. So x is going to be 1. And let's think about like the conditions that we want. So n minus 1 mod 3, that's going to be 3 mod 3, that's equal to 0. Let's go. N minus 1 divided by 3, that's 1. Mod 2 is equal to 1. That works. That's pretty nice. But one thing that we want to know about this is that in a Hailstone sequence, we're always going to terminate with 1. And so even though x is 1, oh, that's not it. Even though x is 1, we're not going to go to 4 because that's the end of our Hailstone sequence. So x equals, the number 1 can't go to any other number in the Hailstone sequence, and therefore it can't go to 4. So that's one other condition that we have to check, where, in particular, we have to check that n minus 1 mod 3 is greater than 1. And so if it's not equal to 1, then we can like do as we please, because like the Hailstone sequence won't stop there. And so those are 3 conditions that we have to check before determining, we can branch out to like that odd number, multiplying by 3 and adding 1. And so if you notice, like for every single path that we had, we always had the option to multiply by 2, because like multiplying by 2 always results in an even number. And because it results in an even number, we can like divide by 2 to get like the original number. And so keeping that in mind, we have 3 conditions, and like let's maybe take a look at our skeleton code. And so we have if some condition, we're going to return something. And so that's going to be the base case, but maybe let's skip that for now. And so we have this other if condition, and we have, space for 3 conditions. How convenient. And so maybe this suggests that our odd condition, like branching to the odd numbers from like 16 branching off to 5, maybe that condition goes right here. And then so what we're going to have is we're going to put all these conditions here essentially. So n minus 1 mod 3 equal to 0. Okay, I'm just going to like label it right here. 1, 2, 3. And put all of them down here. If 1 and 2 and 3. Then what are we going to do? We first have to think about like what branches is though. So in this case, if like the odd like branching was possible, we're going to add it to like the total amount of branches. But we know that the even branching is always possible. So we can always like multiply by 2 and go to like the next level. And so because of that, maybe the even branch should be in this branches right here. Because like if you think about it, branches, since like we're probably like storing like a tree, like a list of trees to act as our branches for when we construct the tree at the end. And I think there's like a line right here. Because of that, we have to like start up with like a certain list. And then we're on the if statement, we're adding the odd branch if it is possible to do so. But the even branch is always possible to do so. So maybe we should like add it here. And so because of that, we're going to make a recursive call on Hailstone tree. And so if we might imagine, how do we generate this part of the tree? The 16, 5, 10, 32, 64. Well, let's try calling like Hailstone tree of 16. And so 16 is going to like branch out into like a 5 and a 32 and like a 5 and like a 10, a 64 and stuff like that until its height reaches like that number. But what do we want our height to be? We want our height to be one less than what we had originally. Because like in total, we want a tree of height h. But then as we like make our subtrees, we want those branches to have height of h minus 1. And like if we branch down, like the 5, 10 branch should like only have height 1, and the 10 branch should only have height 0. And so keeping that in mind, we're going to make a recursive call to create a Hailstone tree of the new number, which is 2 times n if we went down the even branch. And along with that, we're going to decrement the height that we want. So it's going to create a Hailstone tree starting at the term 2 times n, and then with height 1 less than what we had originally. And so along with that, we need to consider like our adding the odd branch. So if you wanted to add the odd branch to the list of branches, we would add Hailstone tree, and it would be like n minus 1 divided by 3, because that's the number we want to do to get to like n, multiplying by 3 and adding 1. So it's going to be n minus 1 for division by 3, just to make sure like our numbers are integers rather than like floats. And so we have n minus 1 divided by 3, and we're also going to decrement the height. So in the case of like 16 to 5 and 10, we want to decrement 1 to the height, so that it doesn't like generate a tree of like height h, resulting in like a total tree of height h plus 1. And so we're going to add that list in, and then we have our branches now, and now we just have to construct the tree. And so constructing the tree, I might erase all of this. Man, this is super cluttered. But what's going to happen is like, we generated our tree in our recursive call. We have this 16 and it's like stored in the list. Well, to create a tree with like the 8 and the 16 tree acting as a branch, we're going to put returning a tree with the label that we have currently, and we want that to be n. So imagine 8, 3. We're starting at the value 8. So we're going to put an 8 right here, or like an n right here, and then we're going to put branches right here. Because the branches list is referring to all the new branches that we created branching off of this. And so in particular, maybe if we called it on like Hailstone tree of 16 with height 2, what's going to happen is that our recursive calls, our branches list is going to be like branch 1, branch 2, and then we're going to create, and this is like contained within the list, and then we're going to create a new tree with a label as 16, and the branches are these 2 branches right here. And yeah, so we kind of like have our recursive call down, and what's left is we think about the base case. And so if we think about the base case once again, typically with like many tree recursion problems, it's going to be like the leaf. And we can find this inside of the doc test up here. And so I'm going to erase this a little bit. And so print tree of Hailstone tree of 1 and 0. And if we want a Hailstone tree of height 0, then we can't go down anymore, because it's like if we like branch down more, we're going to have like height 1 and things like that. So if we have height 0, that means that all we want is the node like n, or like the leaf n. And so because of that, our base case is going to be if it's a leaf. So actually, if it's not a leaf, but rather if its height is going to be 0. So if h is equal to 0, what are we going to return? We're going to return a leaf with the value n. And yeah, that's gonna be Hailstone tree. This is like a pretty difficult problem. I feel like I may have butchered my explanation a couple times. So if you have any questions, like feel free to ask me. I'm always open to it. My email is, let's see, right here. It's gonna be patwang123 at berkeley.edu. And yeah, that's Hailstone tree.